Another way of finding the roots of a quadratic equation is by taking the square roots. Taking square roots method can only be used if the quadratic equation is in the form ax squared plus c is equal to 0, which means that the bx term is missing. Let's have example 1. 2x squared minus 72 is equal to 0. So this given quadratic equation is in the format ax squared plus c equals 0 because the bx term is missing. So since it is in this format, then we can use the square root method. Doing the square root method, the first thing that you need to do is isolate the x square on the left side of the equation, which means that we need to add 72 to both sides, meaning we can transfer negative 72 to the right, and that turns now to positive 72. Isolating the x squared alone, this means we need to divide both sides by 2. And that gives us x squared is equal to 36. So now, to find the value of x that will satisfy x squared equals 36, what should be that x value? 6, right? Because 6 squared will give you 36. Can you think of other number aside from 6 that will give you 36 also when you square it? Negative 6, right? So that's why the answers for the x will be 6 or negative 6. Or you can write it x is equal to plus or minus 6. So we have two values, x equals 6 or x equals negative 6. Or you can write it x is equal to plus minus 6. For our example number 2, we have 1/3 x squared minus 15 is equal to 0. So this quadratic equation is also in this format, so which means we can use the method taking the square roots. Again, step 1 is to isolate the x squared on the left side. So now I will write 1/3 x squared is equal to 15. Now, how do we make the left side only equal to x squared? We have a coefficient of 1/3. So to do that, we can divide both sides by 1/3, or the same thing as multiplying both sides by the reciprocal of 1/3, which is 3/1. And when you multiply 1/3 by 3/1, that's simply 1. So now we have here x squared is equal to 15 times 3/1 is 45. To find the value of x that will satisfy x squared is equal to 45, we need to do the inverse operations. And to do that, we need to get the square root of both sides. And when we do the square root of both sides, we now have plus or minus square root of 45. Since 45 is not a perfect square, we can change that into simplest radical form. And 45 is the same thing as 9 times 5. 9 is a perfect square, and 5 is not. What's the square root of 9? 3. So that means our x value will be plus or minus 3√5. And changing that to decimal, we can simply plug in root 45 or 3√5. So that will give us x is equal to plus or minus 6.71, rounding off the two decimal places. Now let's take a look at example number 3. Number 3 looks different compared to the format ax squared plus c equals 0. So you might think that we need to expand x plus 3 squared, but we will not expand that binomial. What we need to do is transfer negative 4 to the right side, or add 4 to both sides, and that becomes x plus 3 is equal to positive 4. And the same thing, we just need to get the square root of both sides. So when we get the square root of both sides, we now have x plus 3 is equal to plus or minus root 4. And that can be simplified as plus or minus 2. So here we're going to get two values of x. One value of x is equal to negative 3 plus 2, and the other one is negative 3 minus 2. Because this means we need to subtract 3 to both sides. So again, negative 3 plus 2, which is negative 1. And the other one is negative 3 minus 2, and that gives us negative 5. And this means that when we plug in negative 1 back into the equation, negative 1 plus 3 is 2, square it, 4, take away 4, that's true. So this means that negative 1 will make the equation true. Same thing with negative 5. When you plug in negative 5 plus 3 is negative 2, square, that's 4, take away 4, also 0. So negative 1 and negative 5 are the roots of this quadratic equation. Our example number 4 looks different and looks like it's not in this format ax squared plus c is equal to 0. But I'd like you to look at the left side of this equation. Do you notice anything in this trinomial x squared minus 8x plus 16? Ph.D, right? It's a perfect square trinomial. So since it is a perfect square trinomial, then we can factor this as x minus 4 to the second power. And the right side, we have 81. So now, from this example, we were able to rewrite it into this format. X minus 4 squared is equal to 81. Now we're ready to get the square root of both sides. So when we take the square root of both sides, you will have x minus 4. Right side, what's the square root of 81? Plus or minus 9. So adding 4 to both sides of this equation, then the two values for x will be x is equal to 4 plus 9, and the other one is 4 minus 9. Which means the values of x that will make this equation true are 13 and negative 5. Again, you can check whether these two answers, 13 and negative 5, are true by substituting them back into the quadratic equation. For our example number 5, we have 2 parentheses x plus 4 squared is equal to 242. What do you think is the first step? Yes, we need to clear out that 2 by dividing both sides by 2. And this can be simplified as x plus 4 squared is equal to, dividing this will give you 1, 2, 1. Now, this is in the format ax squared plus c is equal to 0. So we're ready to get the square root of both sides. When we get the square root of both sides, we have x plus 4 is equal to plus or minus square root of 121 is 11, because 11 squared will give you 121. The same thing, solving for x by itself, we have minus 4 to both sides, and that gives us x is equal to negative 4 plus 11, which is 7, and the other is negative 4 minus 11, and we have negative 15. So the two values for x that will make this equation true are 7 and negative 15. Taking square roots is not a difficult method, but this method can only be used if you have a quadratic equation in this format. It's like with factoring. You can only use it if the given quadratic equation is factorable.